Advances in technology mean that drones are increasingly used in society to support diverse tasks such as emergency response. For example, they can be used by firefighters to create thermal maps of burning buildings, to map out hotspots, or to search for victims in windows. They could also be used for search and rescue. Here we show live imagery from a demo we conducted in the spring of 2018 with the South Bend firefighters. Multiple drones autonomously flew search routes over the river while firefighters conducted a training exercise. In this example, 2 of our undergraduate students created a drone-based system for dispatching defibrillator devices. In fact, drones are already used by emergency responders. However, in current practice, they tend to be manually operated by a remote pilot. The fire at Notre Dame Cathedral was a highly visible example of this, where drones were used to capture a bird's eye view of a fire. In contrast, our vision is for drones to serve as intelligent partners in emergency response, making autonomous decisions as fully fledged members of the emergency response team. In addition to autonomy, drones need the ability to collaborate with other drones to achieve mission objectives, and they need to interact with humans as team members. We're building our solution over our existing Dronology platform, which supports the coordinated flight of multiple drones. In this mock-up of a river rescue scenario, drones have been dispatched to search the river. They plan their own routes, use onboard image detection, and when a victim is sighted, they dynamically switch to tracking mode and notify human responders. Part of this challenge is detecting victims with high degrees of confidence, even though they might be partially submerged, or the weather conditions might provide low visibility. This part of the project is tackled by Professor Walter Shirer's team from the Computer Vision Research Lab. We're working with the South Bend Fire Department to explore human-drone interactions. For example, the firefighters like the idea of drone autonomy. However, when a drone raises a victim alert, they want a human to confirm or refute the sighting. This user interface is designed to support this human-drone interaction in a fast-paced, high-stress situation. So the question is, how does all of this work? Well, DroneResponse is driven by multiple cooperating AI components distributed across individual drones and a central controller. Here we see an example of a goal model that's used to allocate tasks to drones in ways that optimize the mission outcomes. To see our vision for drone response become a reality, we have to address many open challenges in human-drone interfaces, vision, and autonomy. And last but not least, deployment of drones in urban environments requires an emphasis on safety and an open and meaningful exploration of the societal impacts.